Okay, example 2 in 8.1 for Math 30-1, looking at some more complex equations involving the logarithm. All of these are done by switching from log form to exponential form and vice versa. And as you get better and better at this, you might not have to do that, but at least initially, that is going to be the technique that we focus on. So when I look at log base 5 of x is equal to -3, I am going to take, and I'm going to draw the loop for this one, the base has an exponent of the value, and that's equal to the argument. So what this logarithm is telling me is that 5 to the power of -3 is equal to x. Well, 5 to the power of -3 is 1 over 5 cubed, and 1 over 5 cubed, or 5 cubed itself, is 125. So I get that x is 1 over 125, and I wrote that badly there. Now, that's one of those things that, again, is very, very checkable via your calculator. If you wanted to check this, you should type in, is the log of 1 divided by 125 divided by the log of 5 equal to 3? And that's just trying to build that competency with our change of base formula there. All right, for B, we have log base x of 36 is equal to 2. I am, again, just going to switch that into exponential form, and that is the base to the power of the argument is equal to 36. Now, one of the things that we are going to do in high school math is if we have y equals log base c of x, we are going to talk about how the base of your logarithm has to be greater than 1. I'm just going to put that the base of the logarithm must be greater than 0, but cannot equal to 1. You won't see very many decimal bases, but they can happen. But really importantly, the inside, the argument of the logarithm, has to be positive. It cannot be a negative value. It can't be 0. And the logic behind that is if I look at what this graph is, or what that function is, in exponential form, it's c to the power of y is equal to x. Now, this is going to come up later in the course, that c to the power of y is equal to x is actually the inverse of an exponential function that we've looked at before, and we'll deal with that in the next example. The reason I bring that up is because normally when we would solve this, I would say that x is equal to the positive negative root of 36, but x for this question is the base, so we would just say that it is only the positive root of 36, therefore x is only 6. That's going to be a pretty important consideration, that when we solve logarithms, neither the base nor the argument can be negative. The value, on the other hand, can be negative. And you look back at, part A had a negative value and it still had a solution. So the argument and the base must be positive. All right, for C, it's log base 64. Oh, I missed it, sorry. Log base 64 of x is equal to 2/3. That means that 64 to the power of 2/3 is equal to x. That's the base to the power of the argument the base to the power of the value is equal to the arguments, my bad. To solve this, there's definitely a couple different ways of doing it. Most students just want to grab their calculator right away. Just got to erase that dot. It looks like I'm talking about 6.4 there, but this is 64 to the power of 2/3. I am going to do this piece by piece. I don't know what 64 squared is, so I'm not going to do that first. But I am going to write this 64 to the power of 2/3 as 64 to the power of 1/3. So that's the cube root of 64. And then after that, I'm going to square it. And being able to rewrite exponents like this is very, very important, because everyone in this class should be able to take the cube root of 64, right? It's 4. And then once we do that, it is much more reasonable to take 4 and square it than it is to square 64, which is what the original expression was saying. So 4 squared is 16, and I get that 16 is equal to x. So log base 64 of 16 is equal to 2/3. And one more time, I want to show how to put this onto the calculator. This is log base 10 of 16 divided by log base 10 of 64. That should be equal to 2/3. And I'll show that really quickly. Keep in mind that 2/3 is 0.66 repeating. So when I take log base 10 of 16 and divide it by log base 10 of 64, I get that 2/3 value, which you could see on your calculator with MathFrac.